Spanning 304 hectares along the Brisbane River, the Northshore Hamilton precinct is Queensland's largest urban renewal project. It is a multi-billion-dollar waterfront development engineered to house 24,500 residents among high-rise towers, retail spaces, and public promenades. But building right on the water's edge constantly exposes this massive infrastructure to a relentless, heavy environmental load. The very location that creates the property's value also generates compounded, invisible wear that actively tears at its materials. The primary threat travels through the air. A continuous aerosol of salt spray from the Brisbane River mixes with subtropical humidity, drifting inland and blanketing every exposed surface within a 10-kilometer radius. And when that subtropical moisture eventually evaporates, it leaves behind a dense, highly concentrated network of destructive minerals. These mineral deposits immediately begin interacting with the building. They accelerate degradation of architectural facades, dry out and crack waterproofing membranes, and trigger rapid corrosion in metals. Routine cleaning in this environment acts as a structural defense system deployed to stop the multi-billion-dollar ecosystem from corroding away. The most visible targets in Northshore Hamilton are the high-rise towers. Their irregular, river-facing architectural profiles make conventional cleaning platforms and ladders completely ineffective. Navigating these complex glass geometry safely requires IRATA-certified rope access technicians. Suspended hundreds of feet in the air, these crews can position themselves precisely along any point of the facade. The chemistry of the wash introduces another hurdle. Standard tap water leaves a white mineral residue that binds to the surface, ruining the aesthetic. To combat this, the technicians pump up deionized water, water that has been entirely stripped of its natural salts and minerals. Tap water leaves heavy mineral payloads, while deionized water acts like a sponge, absorbing river salt and evaporating completely clean. Next, hydrophobic nanocoatings are applied. This microscopic treatment forces incoming salt spray to form tight spheres that sheet rapidly off the glass, completely preventing pooling. This exact combination, industrial rope access paired with advanced surface chemistry, protects the optical clarity of the towers, preserving both the property value and the tenant experience inside. Moving down to the mid-rise balconies, the environmental dynamics shift. Here, the most vulnerable zones on the building are actually the sheltered underhangs and deep recesses. Because these sheltered areas receive no natural rain, they are never passively rinsed. Airborne river salt drifts into these pockets and concentrates endlessly over time. When standard 304 stainless steel is installed in these locations, this extreme chloride exposure triggers a highly localized, destructive process known as pitting corrosion. Concentrated salt ions attack the metal's passive film, boring microscopic, jagged pits into the steel lattice and weakening its integrity. The countermeasure is upgrading to marine-grade 316L steel. This alloy is injected with molybdenum, physically repelling chloride attacks and preventing pitting from taking hold. Directly below these metal fixtures, the balcony floors face their own siege. Quarterly washing schedules must be rigorously maintained here to dissolve accumulated salt crystals before their sharp edges can tear microscopic holes in the waterproofing membranes. Surviving a waterfront environment demands these specific, proactive metallurgical choices, backed by scheduled membrane washing to prevent catastrophic structural leaks. At ground level, the Northshore Hamilton precinct opens up into heavy traffic retail hubs and ferry terminals, where structural defense meets public interaction. These wide-open podium levels regularly absorb the blunt force of subtropical summer storms, which deposit massive amounts of organic branch and leaf debris across the hardscapes. In Brisbane's severe humidity, wet leaf litter sitting on concrete becomes an aggressive biological threat. If the debris isn't cleared within 24 hours, rapidly expanding colonies of mold and lichen take root in the porous stone. Removing this growth requires a specific technical balance. Traditional high-pressure washing strips the mold, but the force can also polish the stone smooth, destroying the surface's engineered slip resistance and creating a safety hazard. The solution relies on chemical pretreatment agents paired with a low-pressure water stream. This method gently dissolves and lifts the biological matter from the deep crevices, while leaving the jagged, slip-resistant peaks of the concrete completely intact. Managing these heavy footfall areas requires a precise balancing act. Maintaining an extreme standard of cleanliness must never come at the cost of engineered public safety. This precise maintenance requires thousands of liters of water, introducing a final operational challenge. You cannot defend a waterfront precinct by washing toxic chemical and salt runoff directly back into the adjacent river. During large-scale cleaning operations, heavy mechanical filtration systems are deployed at the drainage sites to intercept the rushing wash water before it escapes. Advanced water reclamation systems capture, filter, and recycle this runoff on-site. This neutralizes the chemical load and significantly reduces the strain on the city's broader stormwater network. These rigorous baseline standards are established early. Even before the first residents arrive, careful post-construction cleans are executed to safely capture harsh curing sealants and abrasive concrete dust left behind by the builders. Strict environmental compliance achieves two distinct goals. It creates the mechanism that protects the built infrastructure while simultaneously ensuring the survival of the natural ecosystem surrounding it. Massive waterfront megaprojects do not passively endure the elements. Left unattended, a river-facing development is in a state of continuous, aggressive decay. Fighting that decay requires a highly synchronized triad of defense: integrated facilities management, advanced material science, and the specialized labor of skilled technicians. Behind the pristine illusion of the million-dollar waterfront lifestyle is an invisible, relentless siege of maintenance. It is the only reason these structures will survive for decades to come.